Knowledge discovery in databases, KDD. The KDD method is a complex and iterative approach to knowledge extraction from big data. Extraction of knowledge from massive data is accomplished through the intricate and iterative KDD process. It is an extensive method that includes data mining as one of its steps. It includes utilizing a variety of algorithms and statistical methods to sort through large amounts of data and identify relevant and valuable data. KDD process steps. Knowledge discovery in the database process includes the following steps, such as goal identification, develop and understand the application domain and the relevant prior knowledge and identify the KDD process's goal from the customer perspective. Creating a target data set, selecting the data set or focusing on a set of variables or data samples on which the discovery was made. Data cleaning and pre-processing. Basic operations include removing noise if appropriate, collecting the necessary information to model or account for noise, deciding on strategies for handling missing data fields. Data reduction and projection, finding useful features to represent the data depending on the purpose of the task. The effective number of variables under consideration may be reduced through dimensionality reduction methods or conversion. Matching process objectives. KDD with Step 1, a method of mining particular. For example, summarization, classification, regression, clustering, and others. Modeling and exploratory analysis and hypothesis selection, choosing the algorithms or data mining and selecting the method or methods to search for data patterns. This process includes deciding which model and parameters may be appropriate and the matching of data mining methods, particularly with the general approach of the KDD process. Data mining, the search for patterns of interest in a particular representational form or a set of these representations, including classification rules or trees, regression, and clustering. The user can significantly aid the data mining method to carry out the preceding steps properly. Presentation and evaluation, interpreting mined patterns, possibly returning to some of the steps between steps 1 and 7 for additional iterations. This step may also involve the visualization of the extracted patterns and models or visualization of the data given the models drawn. Taking action on the discovered knowledge, using the knowledge directly, incorporating the knowledge in another system for further action, or simply documenting and reporting to stakeholders. This process also includes checking and resolving potential conflicts with previously believed knowledge, or extracted. Applications of KDD. Business and marketing, user analysis, market prediction, segmenting clients, and focused marketing are all examples of business and marketing databases. Manufacturing, predictive system analysis, process improvement, and quality control. Finance, fraud investigation, evaluation of credit risk, and stock market research in the finance sector can be analyzed using the KDD method. Healthcare, drug progress, patient monitoring, and disease diagnosis from a large set of patient data. Scientific research, identifying patterns in massive scientific databases, such as genetics, astronomy, and climate. Data mining vs KDD. Key features. Data mining. KDD. Basic definition. Data mining is the process of identifying patterns and extracting details about big data sets using intelligent methods. The KDD method is a complex and iterative approach to knowledge extraction from big data. Goal: to extract patterns from data sets. To discover knowledge from data sets. Scope: in the KDD method, the fourth phase is called data mining. KDD is a broad method that includes data mining as one of its steps. Used techniques: classification, clustering, decision trees, dimensionality reduction, neural networks, regression, data cleaning, data integration, data selection, data transformation, data mining, pattern evaluation, knowledge presentation. Example: clustering groups of data elements based on how similar they are. Data analysis to find patterns and links. Mining issues. Data mining is not an easy task, as the algorithms used can get very complex and data is not always available at one place. It needs to be integrated from various heterogeneous data sources. Factors that create some issues: mining methodology and user interaction issues, performance issues, diverse data types issues, mining methodology and user interaction issues. Mining different kinds of knowledge in databases. Different users may be interested in different kinds of knowledge. Therefore, it is necessary for data mining to cover a broad range of knowledge discovery tasks. Interactive mining of knowledge at multiple levels of abstraction. The data mining process needs to be interactive because it allows users to focus the search for patterns, providing and refining data mining requests based on the returned results. Incorporation of background knowledge to guide discovery process and to express the discovered patterns. The background knowledge can be used. Background knowledge may be used to express the discovered patterns not only in concise terms but at multiple levels of abstraction. Data mining query languages and ad hoc data mining. Data mining query language that allows the user to describe ad hoc mining tasks should be integrated with a data warehouse query language and optimized for efficient and flexible data mining. Presentation and visualization of data mining results. Once the patterns are discovered, it needs to be expressed in high-level languages and visual representations. These representations should be easily understandable. Handling noisy or incomplete data. The data cleaning methods are required to handle the noise and incomplete objects while mining the data regularities. If the data cleaning methods are not there, then the accuracy of the discovered patterns will be poor. Pattern evaluation. The patterns discovered should be interesting or relevant. Performance issues. Efficiency and scalability of data mining algorithms. In order to effectively extract the information from huge amount of data in databases, data mining algorithm must be efficient and scalable. Parallel, distributed, and incremental mining algorithms. The factors such as huge size of databases, wide distribution of data, and complexity of data mining methods motivate the development of parallel and distributed data mining algorithms. These algorithms divide the data into partitions which is further processed in a parallel fashion. Then the results from the partitions is merged. The incremental algorithms update databases without mining the data again from scratch. Diverse data types issues. Handling of relational and complex types of data. The database may contain complex data objects, multimedia data objects, spatial data, data related to a specific location on the Earth's surface, etc. It is not possible for one system to mine all these kind of data. Mining information from heterogeneous databases and global information systems. The data is available at different data sources on LAN or WAN. These data source may be structured, semi-structured, or unstructured. Therefore, mining the knowledge from them adds challenges to data mining. Data mining metrics. Data mining metrics may be defined as a set of measurements which can help in determining the efficacy of a data mining method or algorithm. They are important to help take the right decision as choosing the right data mining technique or algorithm. Evaluation metrics can be divided into two main categories: predictive, descriptive. Predictive metrics evaluate how well the model can predict the outcome of new or unseen data, based on the data it was trained on. They are often used for supervised data mining tasks, such as classification or regression. Examples: accuracy, precision, recall, F1 score, mean squared error, and ROC curve. Descriptive metrics evaluate how well the model can capture the structure, patterns, or relationships in the data, without a predefined outcome. They are often used for unsupervised data mining tasks, such as clustering or association rule mining. Examples: silhouette coefficient, Davies-Bouldin index, support, confidence, and lift. How to choose the right evaluation metric. Selecting the most suitable evaluation metric for data mining is a complex task since it depends on various elements and compromises. Nevertheless, by adhering to certain general rules, you can make a more educated and reasonable decision, and consequently enhance the quality and usefulness of your data mining outcomes. Define your objective. What are you trying to achieve or optimize? This will help guide the choice of evaluation metric, as different metrics may reflect different aspects of the model performance. Be aware of the data. What are the features, variables, and distributions? How are they associated with the outcome or target variable? Compare and validate the results. Comparison and validation methods should influence the selection of evaluation metric, as different metrics may have different scales, ranges, or interpretations. Social implications on data mining. There are various social implications of data mining which are as follows. Privacy. In current years, privacy concerns have taken on a more important role as merchants, insurance companies, and government agencies amass warehouses including personal records. The concerns that people have over the group of this data will generally extend to some analytic capabilities used to the data. Users of data mining should start thinking about how their use of this technology will be impacted by legal problems associated with privacy. Profiling. Data mining and profiling is a developing field that attempts to organize, understand, analyze, reason, and use the explosion of data in this information age. The process contains using algorithms and experience to extract design or anomalies that are very complex, difficult, or time-consuming to recognize. Unauthorized used trends obtained through data mining designed to be used for marketing goals or some other ethical goals, can be misused. Unethical businesses or people can use the data obtained through data mining to take benefit of vulnerable people or discriminate against a specific group of people. Furthermore, the data mining technique is not 100% accurate, thus mistakes do appear which can have serious results. Data mining from a database perspective. A data mining system can be classified according to the kinds of databases on which the data mining is performed. For example, a system is a relational data miner if it discovers knowledge from relational data, or an object-oriented one if it mines knowledge from object-oriented databases. Statistical methods in data mining. Data mining refers to extracting or mining knowledge from large amounts of data. In other words, data mining is the science, art, and technology of discovering large and complex bodies of data in order to discover useful patterns. Theoreticians and practitioners are continually seeking improved techniques to make the process more efficient, cost-effective, and accurate. Any situation can be analyzed in two ways in data mining. Non-statistical analysis. This analysis provides generalized information and includes sound, still images, and moving images. Statistical analysis. In statistics, data is collected, analyzed, explored, and presented to identify patterns and trends. Alternatively, it is referred to as quantitative analysis. It is the analysis of raw data using mathematical formulas, models, and techniques. Through the use of statistical methods, information is extracted from research data, and different ways are available to judge the robustness of research outputs. It is created for the effective handling of large amounts of data that are generally multidimensional and possibly of several complex types. Statistical analysis is a scientific tool in AI and ML that helps to collect and analyze large amounts of data to identify common patterns and trends to convert them into meaningful information. In simple words, statistical analysis is a data analysis tool that helps draw meaningful conclusions from raw and unstructured data. The conclusions are drawn using statistical analysis, facilitating decision-making and helping businesses make future predictions on the basis of past trends. It can be defined as a science of collecting and analyzing data to identify trends and patterns and presenting them. Statistical analysis involves working with numbers and is used by businesses and other institutions to make use of data to derive meaningful information. Types of statistical analysis. Descriptive statistical analysis involves collecting, interpreting, analyzing, and summarizing data to present them in the form of charts, graphs, and tables. Rather than drawing conclusions, it simply makes the complex data easy to read and understand. The inferential statistical analysis focuses on drawing meaningful conclusions on the basis of the data analyzed. It studies the relationship between different variables or makes predictions for the whole population. Predictive statistical analysis is a type of statistical analysis that analyzes data to derive past trends and predict future events on the basis of them. It uses machine learning algorithms, data mining, data modeling, and Artificial intelligence to conduct the statistical analysis of data. The prescriptive analysis conducts the analysis of data and prescribes the best course of action based on the results. It is a type of statistical analysis that helps you make an informed decision. Exploratory analysis is similar to inferential analysis, but the difference is that it involves exploring the unknown data associations. It analyzes the potential relationships within the data. The causal statistical analysis focuses on determining the cause and effect relationship between different variables within the raw data. In simple words, it determines why something happens and its effect on other variables. This methodology can be used by businesses to determine the reason for failure. Importance of statistical analysis. Statistical analysis eliminates unnecessary information and catalogs important data in an uncomplicated manner, making the monumental work of organizing inputs appear so serene. Once the data has been collected, statistical analysis may be utilized for a variety of purposes. The statistical analysis aids in summarizing enormous amounts of data into clearly digestible chunks. The statistical analysis aids in the effective design of laboratory, field, and survey investigations. Statistical analysis may help with solid and efficient planning in any subject of study. Statistical analysis aid in establishing broad generalizations and forecasting how much of something will occur under particular conditions. Statistical methods, which are effective tools for interpreting numerical data, are applied in practically every field of study. Statistical approaches have been created and are increasingly applied in physical and biological sciences, such as genetics. Statistical approaches are used in the job of a businessman, a manufacturer, and a researcher. Statistics departments can be found in banks, insurance businesses, and government agencies. A modern administrator, whether in the public or commercial sector, relies on statistical data to make correct decisions. Politicians can utilize statistics to support and validate their claims while also explaining the issues they address. Benefits of statistical analysis. Statistical analysis can be called a boon to mankind and has many benefits for both individuals and organizations. Given below are some of the reasons why you should consider investing in statistical analysis. It can help you determine the monthly, quarterly, yearly figures of sales profits and costs, making it easier to make your decisions. It can help you make informed and correct decisions. It can help you identify the problem or cause of the failure and make corrections. For example, it can identify the reason for an increase in total costs and help you cut the wasteful expenses. It can help you conduct market analysis and make an effective marketing and sales strategy. It helps improve the efficiency of different processes. Statistical analysis methods. Although there are various methods used to perform data analysis, given below are the 5 most used and popular methods of statistical analysis. Mean or average mean is one of the most popular methods of statistical analysis. Mean determines the overall trend of the data and is very simple to calculate. Mean is calculated by summing the numbers in the data set together and then dividing it by the number of data points. Despite the ease of calculation and its benefits, it is not advisable to resort to mean as the only statistical indicator, as it can result in inaccurate decision-making. Standard deviation. Standard deviation is another very widely used statistical tool or method. It analyzes the deviation of different data points from the mean of the entire data set. It determines how data of the data set is spread around the mean. You can use it to decide whether the research outcomes can be generalized or not. Regression. Regression is a statistical tool that helps determine the cause and effect relationship between the variables. It determines the relationship between a dependent and an independent variable. It is generally used to predict future trends and events. Hypothesis testing. Hypothesis testing can be used to test the validity or trueness of a conclusion or argument against a data set. The hypothesis is an assumption made at the beginning of the research and can hold or be false based on the analysis results. Sample size determination. Sample size determination or data sampling is a technique used to derive a sample from the entire population, which is representative of the population. This method is used when the size of the population is very large. You can choose from among the various data sampling techniques such as snowball sampling, convenience sampling, and random sampling. Data mining techniques. In recent data mining projects, various major data mining techniques have been developed and used. 1. Classification. This technique is used to obtain important and relevant information about data and metadata. This data mining technique helps to classify data in different classes. Data mining techniques can be classified by different criteria, as follows. Classification of data mining frameworks as per the type of data sources mined. This classification is as per the type of data handled. For example, multimedia, spatial data, text data, time series data, World Wide Web, and so on. Classification of data mining frameworks as per the database involved. This classification based on the data model involved. For example, object-oriented database, transactional database, relational database, and so on. Classification of data mining frameworks as per the kind of knowledge discovered. This classification depends on the types of knowledge discovered or data mining functionalities. For example, discrimination, classification, clustering, characterization, etc. Some frameworks tend to be extensive frameworks offering a few data mining functionalities together. Classification of data mining frameworks according to data mining techniques used. This classification is as per the data analysis approach utilized, such as neural networks, machine learning, genetic algorithms, visualization, statistics, data warehouse-oriented or database-oriented, etc. 2. Clustering. Clustering is a division of information into groups of connected objects. Describing the data by a few clusters mainly loses certain confined details, but accomplishes improvement. It models data by its clusters. In other words, we can say that clustering analysis is a data mining technique to identify similar data. This technique helps to recognize the differences and similarities between the data. Clustering is very similar to the classification, but it involves grouping chunks of data together based on their similarities. 3. Regression. Regression analysis is the data mining process used to identify and analyze the relationship between variables because of the presence of the other factor. It is used to define the probability of the specific variable. Regression, primarily a form of planning and modeling. For example, we might use it to project certain costs, depending on other factors such as availability, consumer demand, and competition. Primarily it gives the exact relationship between two or more variables in the given data set. 4. Association rules. This data mining technique helps to discover a link between two or more items. It finds a hidden pattern in the data set. Association rules are if-then statements that support to show the probability of interactions between data items within large data sets in different types of databases. For example, a list of grocery items that you have been buying for the last 6 months. It calculates a percentage of items being purchased together. These are 3 major measurements technique, lift support confidence. 5. Outlier detection. This type of data mining technique relates to the observation of data items in the data set, which do not match an expected pattern or expected behavior. This technique may be used in various domains like intrusion detection, fraud detection, etc. It is also known as outlier analysis or outlier mining. The outlier is a data point that diverges too much from the rest of the dataset. The majority of the real-world datasets have an outlier. Outlier detection plays a significant role in the data mining field. Outlier detection is valuable in numerous fields like network interruption identification, credit or debit card fraud detection, detecting outlying in wireless sensor network data, etc. 6. Sequential patterns. The sequential pattern is a data mining technique specialized for evaluating sequential data to discover sequential patterns. It comprises of finding interesting subsequences in a set of sequences, where the stake of a sequence can be measured in terms of different criteria like length, occurrence frequency, etc. In other words, this technique of data mining helps to discover or recognize similar patterns in transaction data over some time. 7. Prediction. Prediction uses a combination of other data mining techniques such as trends, clustering, classification, etc. It analyzes past events or instances in the right sequence to predict a future event. Similarity measure. Similarity measures are mathematical functions used to determine the degree of similarity between two data points or objects. These measures produce a score that indicates how similar or alike the two data points are. It takes two data points as input and produces a similarity score as output, typically ranging from 0, completely dissimilar, to 1, identical or perfectly similar. Similarity measures also have some well-known properties. Sim, AB, equals 1 similarity, only if A equals B. Typical range, 0 less than or equal to sim less than or equal to 1. Symmetry, sim, AB, equals sim, BA, for all A and B. Most commonly used similarity measures in data mining. Cosine similarity. Cosine similarity is a widely used similarity measure in data mining and information retrieval. It measures the cosine of the angle between two non-zero vectors in a multidimensional space. In the context of data mining, these vectors represent the feature vectors of two data points. The cosine similarity score ranges from 0 to 1, with 0 indicating no similarity and 1 indicating perfect similarity. The cosine similarity between two vectors is calculated as the dot product of the vectors divided by the product of their magnitudes. This calculation can be represented mathematically as follows. Cos theta equals a dot b slash ab, where a and b are the feature vectors of two data points. Dot denotes the dot product, and denotes the magnitude of the vector. Jagged similarity. The jagged similarity is another widely used similarity measure in data mining, particularly in text analysis and clustering. It measures the similarity between two sets of data by calculating the ratio of the intersection of the sets to their union. The jagged similarity score ranges from 0 to 1, with 0 indicating no similarity and 1 indicating perfect similarity. The jagged similarity between two sets A and B is calculated as follows. J, AB, equals a mathematical intersection symbol B slash a union set symbol B. Where a mathematical intersection symbol B is the size of the intersection of sets A and B, and a union set symbol B is the size of the union of sets A and B. Pearson correlation coefficient. The Pearson correlation coefficient is a widely used similarity measure in data mining and statistical analysis. It measures the linear correlation between two continuous variables, x and y. The Pearson correlation coefficient ranges from -1 to +1, with -1 indicating a perfect negative correlation, 0 indicating no correlation, and +1 indicating a perfect positive correlation. The Pearson correlation coefficient is commonly used in data mining applications such as feature selection and regression analysis. It can help identify variables that are highly correlated with each other, which can be useful for reducing the dimensionality of a dataset. In regression analysis, it can also be used to predict the value of one variable based on the value of another variable. The Pearson correlation coefficient between two variables, x and y, is calculated as follows. Rho, xy, equals COV, xy, slash sigma x sigma y. Where COV, xy, is the covariance between variables x and y, and sigma x and sigma y are the standard deviations of variables x and y, respectively. Sorensen-Dice coefficient. The Sorensen-Dice coefficient, also known as the Dice similarity index or Dice coefficient, is a similarity measure used to compare the similarity between two sets of data, typically used in the context of text or image analysis. The coefficient ranges from 0 to 1, with 0 indicating no similarity and 1 indicating perfect similarity. The Sorensen-Dice coefficient is commonly used in text analysis to compare the similarity between two documents based on the set of words or terms they contain. It is also used in image analysis to compare the similarity between two images based on the set of pixels they contain. The Sorensen-Dice coefficient between two sets, A and B, is calculated as follows. S, AB, equals to a mathematical intersection symbol B slash A plus B. Where a mathematical intersection symbol B is the size of the intersection of sets A and B are the sizes of sets A and B, respectively. Choosing the appropriate similarity measure. Choosing an appropriate similarity measure depends on the nature of the data and the specific task at hand. Some factors to consider when choosing a similarity measure. Different similarity measures are suitable for different data types, such as continuous or categorical data, text or image data, etc. For example, the Pearson correlation coefficient, which is only suitable for continuous variables. The choice of similarity measure also depends on the specific task at hand. For example, cosine similarity is often used in information retrieval and text mining, while jacket similarity is commonly used in clustering and recommendation systems. Some similarity measures are more robust to noise and outliers in the data than others. For example, the Sorensen-Dice coefficient is less sensitive to noise. Decision tree. A decision tree is a type of supervised learning algorithm that is commonly used in machine learning to model and predict outcomes based on input data. It is a tree-like structure where each internal node tests on attribute, each branch corresponds to attribute value, and each leaf node represents the final decision or prediction. Example of a decision tree. Suppose we want to build a decision tree to predict whether a person is likely to buy a new car based on their demographic and behavior data. The decision tree starts with the root node, which represents the entire dataset. The root node splits the dataset based on the income attribute. If the person's income is less than or equal to $50,000, the decision tree follows the left branch, and if the income is greater than $50,000, the decision tree follows the right branch. The left branch leads to a node that represents the age attribute. If the person's age is less than or equal to 30, the decision tree follows the left branch, and if the age is greater than 30, the decision tree follows the right branch. The right branch leads to a leaf node that predicts that the person is unlikely to buy a new car. The left branch leads to another node that represents the education attribute. If the person's education level is less than or equal to high school, the decision tree follows the left branch, and if the education level is greater than high school, the decision tree follows the right branch. The left branch leads to a leaf node that predicts that the person is unlikely to buy a new car. The right branch leads to another node that represents the credit score attribute. If the person's credit score is less than or equal to 650, the decision tree follows the left branch, and if the credit score is greater than 650, the decision tree follows the right branch. The left branch leads to a leaf node that predicts that the person is unlikely to buy a new car. The right branch leads to a leaf node that predicts that the person is likely to buy a new car. In summary, a decision tree is a graphical representation of all the possible outcomes of a decision based on the input data. It is a powerful tool for modeling and predicting outcomes in a wide range of domains, including business, finance, healthcare, and more. Decision tree algorithm. Begin with the entire dataset as the root node of the decision tree. Determine the best attribute to split the dataset based on a given criterion. Create a new internal node that corresponds to the best attribute and connects it to the root node. Partition the dataset into subsets based on the values of the best attribute. Recursively repeat steps 1 to 4 for each subset until all instances in a given subset belong to the same class or no further splitting is possible. Assign a leaf node to each subset that contains instances that belong to the same class. Make predictions based on the decision tree by traversing it from the root node to a leaf node that corresponds to the instance being classified. The benefits of having a decision tree are: it does not require any domain knowledge. It is easy to comprehend. The learning and classification steps of a decision tree are simple and fast. The following decision tree is for the concept to buy computer that indicates whether a customer at a company is likely to buy a computer or not. Each internal node represents a test on an attribute. Each leaf node represents a class.